Okay, and now we're on the very last page. We've lost negatives and pies for a lot of these, so I'm going to go through and fill those in. You all do have them on your printed off worksheets, but I would like to have the same thing that we're looking at there. So here's the deal with the reference angle. Like I said on the previous page, it really is having to do with where the angle is. Actually, I think I'm going to start with this second one right here. I'm going to start with D. So there's a couple different ways to think about it. What's really going on beneath it is you're looking at how far is the angle from the x-axis, or how far have you traveled. So if I'm going negative 2 pi over 3, that means I'm going to start at my initial side and go clockwise. Remember, because it's negative, I need to go clockwise. So 2 pi over 3s, the pi over 3s kind of come like this. So I go 1 pi over 3, 2 pi over 3. And there's my terminal side for negative 2 pi over 3. So that's where negative 2 pi over 3 is. The whole deal with the reference angle is how far away am I from the x-axis? So how much of a thing is that? And if I'm going from 2 pi over 3 or even negative 2 pi over 3 to negative pi, how much do I have left? I have pi over 3. So the reference angle, whoopsie, which we tend to write as theta reference, is going to be pi over 3, because that's how far I'm going to get from 2 pi over 3 to 3 pi over 3. Whether they're both negative or both positive, the difference between them is pi over 3. Okay, so notice I have 2 pi over 3. The denominator is 3. The denominator of the reference angle is 3. And that's essentially what you're doing on all of these. You are looking at what the denominator is, and that's going to determine your reference angle. If you look at E, the worked out example E, 7 pi over 6, that's just essentially one more pi over 6 than pi itself, right? 6 pi over 6 is pi. So this is 7 pi over 6. And you can turn back to your other page, your previous page, and you can kind of see where all of these are. So if I'm looking at how far away I am there, well, if I'm going from 6 pi over 6 to 7 pi over 6, how far am I traveling? Pi over 6. That's how far I'm traveling. So here is the reference angle for it, pi over 6. And again, you have a 6 in the denominator of your original angle. That means that the reference angle is going to have a 6 in its denominator. Basically, if you have a 3 in the denominator, once you've reduced anything down that needs to be reduced, you wind up with a 3 in the denominator, reference angle is pi over 3. 4 in the denominator, reference angle is pi over 4. 6 in the denominator, reference angle is pi over 6, as long as it's been reduced. If I go up to A, and I look at A and I see 8 pi is going to be, well, pi over 3. And if you look at where 8 pi over 3 is, you can see that it's going to be pi over 3 away from your x-axis. Remember, all of these distances are coming from the x-axis. Negative 11 pi over 6. I can't reduce the 11 and the 6. So theta reference is simply pi over 6. I use the same denominator. 27 pi over 4. I can't reduce the 27 and the 4. Theta reference is pi over 4. Negative 7 pi over 4. Can't reduce the 7 and the 4. So theta reference is, again, pi over the denominator. And this last one, I'm willing to bet you're going to say, oh, theta reference is pi over 3, and you would be absolutely correct. So as long as you can't reduce the fraction anymore, your reference angle is simply pi over whatever the denominator happens to be because of where you wind up. Now look at 5 pi. This is very, very interesting. Let's figure out where 5 pi is in the grand scheme of things. So I go here, 5 pi. So let's see, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi puts me right here. That's where it is. How far away am I from the x-axis? I'm right on it. So in this case, we say theta reference is, well, 0 radians. That's what we say. But it kind of doesn't matter for the 5 pi, because remember, what we're using the reference angle for is to figure out what the points would be at that particular place. That's why we have a reference angle. That's why we use it. Well, 5 pi, as long as I know it's where pi is, I know that my point is going to be -1, 0. So that kind of doesn't matter as much to me. Anything on the quadrantals, I'm dealing with the zeros and the ones. I'm not as concerned about it. Now, what you have to do in order to figure out what your points are is to figure out where on the circle you are or what quadrant you're in. So 8 pi over 3, well, you can look back over your pi over 3 stuff, and you will see that for 8 pi over 3, you're going to wind up, oh, gee, it's not even in one turnaround. 8 pi over 3 winds up into the second quadrant, because 6 pi over 3 is 2 pi. Or if I want to look at it this way, I can say, well, I'm starting here, and I'm going 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3. That's where it is. It's quadrant 2. So I look at what are my points for pi over 3. My points for pi over 3, if I'm looking back at the thing we just did, my points for pi over 3 are 1/2 and √3 over 2, but x has to be negative because I'm in quadrant 2. That's how you use reference angles. You figure out if you're working with the pi over 3, the pi over 4, the pi over 6, and then you figure out which quadrant it is, and that'll tell you the points and which one of them is negative or positive. On the next one, I'm still working with the pi over 3's, so I'm still working with an x of 1/2, and that was incorrect. A y of √3 over 2. But now I'm in the third quadrant, so they're both negative. Pi over 6. Anything with pi over 6, I'm going to be working with √3 over 2 and then 1/2 in order to figure out which one's positive and which one's negative. Negative 11 pi over 6 is almost at -2 pi. So I wind up like right here, pi over 6 away, and I'm moving in the negative direction. I wind up in quadrant 1. They're both positive. So this is how you use the reference angles, and we'll be going into this in a little more detail tomorrow in terms of the reference angles. We'll be doing a lot more with them, but this is what they're for. So all in all together, today in these notes, we have found the points for anything that's a pi over 6, anything that's a pi over 3, anything that's a pi over 4. We've got the points. We've seen how the signs of those points will change based on which quadrant you're in. And then we've also explored a little bit how to get a reference angle for anything over a 3 or a 6 or a 4, as long as it's been all the way reduced. And that can tell us what the point is for whatever angle they want to throw at us out of these special ones. So it's kind of cool. Give it a shot tonight on the homework. Definitely. We're going to go more into reference angles tomorrow. So I hope you've gotten kind of to see how cool this is, because it really kind of is. I mean, this stuff just sort of happens. It's really neat. So anyway, hope you've had a good time with this. Do your homework tonight, and I will be back tomorrow. Remember, if you need help, you can go to the MRC. You can come in and see me outside of class. You can do anything you need to do. So thank you for your kind attention.